Okay, this is the second video for section 5. So on word problems, first read through them and figure out what type of a problem they are. So this says a roofing contractor buys 15 bundles of shingles and 8 rolls of roofing paper for $640. So what you're going to do is I like to just go ahead and use a highlighter to kind of clue me into what's what. And so I'm going to highlight that information. Think of this, what I think of it as is like a receipt problem. Like this is one receipt from this roofing contractor. This is one purchase. So then the other thing says in a second purchase, the contractor buys 8 bundles of shingles and 2 rolls of roofing paper for $296. The blue highlighting is the second receipt. So think about like 2 separate purchases or 2 receipts. And we're going to write equations for each receipt. Now it says, find the price per bundle of shingles. So let's let that be X. So X is the price per bundle of shingles. Now when I write down what my variables represent, that's called defining your variables, and it's very important if you struggle at word problems and you make the change to start defining your variables and really slowing down and understanding what the variables represent and how they make the equation, you will get better with practice. So first you must define your variables. Okay, Y is the price per roll of roofing paper. And that's also in dollars. So I feel like for us it's obvious, like, oh, that's dollars, but it's just good to go ahead and notate. Okay, so the first equation is the yellow highlight. 15 bundles of shingles, that's 15 times X, because X was how much a bundle of shingles cost, plus 8 rolls of roofing paper. So that's 8 times Y, because Y is how much a roll of roofing paper costs. Total amount for this purchase was $640. Okay, your other equation in the blue highlight is 8 bundles of shingles, so that's 8X, 2 rolls of roofing paper, that's 2Y, equals $296. Now, what I would recommend doing is going ahead and making a table for each one, because you need to see like how many points you need, how high the x-axis or the y-axis needs to go, how far to the right the x-axis needs to go. You kind of need to know that before you begin. So we're going to make a table for this. So you can use kind of just the side of your paper, but what I'm going to do is I'm going to take this equation, 15x plus 8y equals 640, and I'm going to rearrange it so y is by itself. That'll just make it easier to find points. So first I'm going to subtract the 15x. So now I have 8y equals negative 15x plus 640, and then I divide by 8. All right, I get y equals negative 15 over 8x plus 640 divided by 8 is 80. So now if I just start plugging in some x values, use a calculator to do that. When I plug in x is 0, I get 80. And I know this is going to work out nicely going by 8s. How I know that is because, do you see the slope is over 8? So if you plug in multiples of 8 to x, you're going to get nice whole numbers, which you don't have to have whole numbers to graph, but it sure does work out nicely. If you plug in 8 for x, you get 65. Plug in 16, you get 50. Plug in 24, you're going to get 35. Plug in 32, you get 20. And 40, you get 5. I'm not going to keep going because 48 gives me a negative number, and that just doesn't make sense to have a negative amount of roofing paper. Okay, so for this other equation, for the second purchase, this equation right here, you're going to go ahead and do the same thing where you rearrange it to get y by itself. So the first thing I do is I add or subtract the x. So it's 8x, and I'm going to subtract it. And then the second thing I do is divide by the number in front of y. So I have negative 8x plus 296. Now divide everything by 2. So we get negative, whoops, that's a y, negative 4x plus 296 divided by 2, just calculate it real quick, is 148. Okay, so now we can plug in numbers. When I plug in 0, I get 148. And then I honestly just plugged in some numbers to try to find nice clean ones. When I plugged in 2, I got 140. And I didn't go every 2 because that would be a lot of numbers. So then I jumped and I was like, let's try 12. You could try 10, I don't know. 12 was 100. So now plug in another x value. For example, if I plug in 18, negative 4 times 18 plus 148, that was 76. I plugged in 27, I got 40, just as an example. So just get some points. You need more than just 2 points for a graph with this big of numbers, just to be able to get it to work out nicely. Okay, so let's look at the big picture here. So this is your y-intercept at 80. This is your y-intercept at 148. So I know on my y-axis, I need room to go up to 148. Now I'll tell you, these graphs I put on here are 20 by 20 boxes. So if I go by 5s, that would take me 30 boxes. That's not going to work, so I need to go by 10s on the y-axis. So label this 10, 20, 30, 40, 50. I only label every so often, but they need to be evenly spaced. You can't just randomly choose where 50 goes. So 60, 70, 80, 90, 100. And if you really work to set up your graph neatly, it will turn out so much better. Like, stop and take your time and like write nicely, label the points, you know, make it not to where you just have this huge writing that you can't tell which one's which. Okay, use smaller writing so that you can fit everything on there. And remember, Y is the price per roll of roofing paper. So label your axis. Okay, now look at your X values. Your X values, when I got over to 40, I was like, okay, we're doing pretty good there. So I'd like to get over to 40, maybe even a little farther. Remember, this is 20 boxes. So if I go by 2s, then that would let me get to 40. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. One thing some people do is make like every 10th one like a little darker of a mark so you can tell where it is easier. And the x-axis is the price per bundle of shingles. That was what x was. Okay, let's plot some points. So this first equation I'm going to do in red. All right, so it said 0, 80. All right, that's right here. And then it said 8 was at 65. Okay, 8 and up 65 would be right in between 60 and 70. 16 was up to 50. All right, 24 was at 35, so right between 30 and 40. And 32 was at 20, and 40 was at 5. Okay. So the next thing you want to do is you want to draw on your line. You should use a ruler for these, okay? If you don't use a ruler, then when you go to find your intersection line, your point of intersection, it's going to be just not accurate. So really use a ruler. You see, you can see that I'm using like a straight edge that is offered through the program I'm recording this on, just to try to make sure like I really have this lined up. Okay. And so there's my line for this equation. And I will tell you another recommendation is you don't want your graph just over here in the corner. That's why we use and we try to fill up the whole graph with points that we need. Because if you just have it taking up this little corner right here, it's going to be really hard to show or to see exactly where it intersects. It's going to be really difficult. And so that's why we want to make it spaced out to where everything is very visible. So I try to take up as much of the graph as possible without it being too large. Okay, next we're going to do this one. 0, 48 is about right here. 2, 140, that's really easy to graph. That's why I always pick nice numbers, is because it's just easier to graph. 12, 100. Okay, 1876, here's 18, and then 76, we're just going to have to get close on. So it's about halfway between 70 and 80. And then I also had 2740. Okay, 22, 24, 26, 28, halfway between 26 and 28 and up to 40. And then from there, that's enough points that, once again, use that straight edge, or it's just going to be very difficult to accurately find where the intersection is. So you can see I'm just getting mine on here because of the tool I use. And it doesn't have to be a ruler. You can also use like just the side of your student ID or something just to get a straight line. It doesn't have to have measurements on it. You're just trying to get a really straight line. Okay, I think that's pretty close to going through those points. All right, and you look for the point of intersection. So where it intersects is right here. And so that is the point 3220. And you don't just put that as your answer. X was the price per bundle of shingles. So it's $32 per bundle of shingles. And then the Y value was 20, so it's $20 per roll of roofing paper. And if you're doing this on your homework and they don't provide you with graph paper, just grab some graph paper from my stash or if you have any. And you need to just set it up on a graph to find where the intersections are. Okay, on the second one, let's just go ahead and set it up really quickly. So I want you to go ahead and pause the video and write an equation for the two equations you'll need to solve this. Okay, if X is the price of a child ticket and Y is the price of an adult ticket, here's my two equations. I went ahead and color coded them for you. And then what I did is I went ahead and rearranged these equations. So I'm just going to I a lot of times will just use scratch paper to do it. So I'm going to take that equation for 4x plus 8y equals 128. And you want to rearrange it to where y is by itself. So move the x first. So I subtract it, so I get negative 4x plus 128. Now divide by 8. I get negative 1/2 x plus 128 divided by 8. Use calculator real quick, it's 16. So make your table for that. So we don't need every single number, but when you plug in 0, you get 16. I just tried 4, and when I plugged in 4, I get 14. And I went ahead and went by 4s because it seemed to be working for me. 8 was 12. 12 was 10, and honestly, we could do one more, but that's probably good enough. 16 is 8. So now do the same thing for the other equation. And so you're going to go ahead and you're going to rearrange that 8x plus 6y equals 136. So what would you move first? The 8x, you're going to subtract it from both sides of the equals. So once on the left side of the equals, once on the right side. So that's negative 8x plus 136. And then divide by 6. All right, I left this as a fraction. I left it as negative 4/3 x. And then this is 22 2/3, which is kind of weird. But I'm going to use my calculator to find them, so we're okay. So this one, when I plug in 0, I get like 22 2/3, which is like 22.6 repeating. When I plug in 2, it worked out a lot nicer. I ended up getting 20. I tried plugging in some other numbers and got weird decimals. When I plugged in 8, I was like, okay, that's a good number to graph. Same thing when I plugged in 14. So if I look at them and get kind of weird decimals, I a lot of times will go ahead and just pick a different number. Okay, so on the x-axis, my x's went all the way up to 16, maybe even a little farther. So remember, since this graph paper is 20, you can go by ones down here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and then on the y-axis, I need to go all the way up to 22. And honestly, I just went ahead and went by ones here because I figure my intersection's probably not going to be quite that high. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, go ahead and graph the points. I'm going to pause this so you could do that. Okay, so here's the two lines graphed. Notice I labeled the axes also. So where they intersect, this is at, let's see here, 8 and 12. So 8, 12. So what that means is it is $8 per each child a ticket. Like the child tickets, the cost is $8 and $12 for every adult ticket. And that's your solution.